Okay, here we go. 7.3 sampling distribution for proportions. We've done something really close to this, and I'm not going to try to get, well, here I will get a little bit theoretical on you. But do you remember back when we were doing binomial fitting underneath the normal curve? Okay, if you do, that's good, because a lot of the things that I just wrote down below here have a lot to do with that. You have right here, I'm grab out a nice little, let's go a nice red. You've got N is still the number of trials that something happens, R is the number of successes, P is your probability of success, Q is your probability of failure. Now you're going to come up with a sample statistic now. Instead of X bar, it's going to be what's called P hat, which is the number of successes R over the number of what you want to call them, the trials. Okay, so the idea is that everything about the binomial is going to stay the same as this now. So I'm still going to have to take N times P bigger than 5, N times Q bigger than 5. But now what I'll have is this mean of P hat is the same as my probability of success, or my population probability. And my standard deviation is going to be a little bit different. It's going to be the square root of P times Q divided by N. Okay, so standard error, you got the standard error for P hat. There's the standard deviation, basically this distribution. Not a big deal other than the fact that you need to know, maybe for verbiage reasons, reading through a problem, what that standard error is talking about. Now this continuous correction. Okay, so we did this previously for your R. It's smack dab in the middle of a rectangle, and depending on what type of a rectangle or what side, I needed to add or subtract the 0.5. Well, now since this spot is a P hat, or R divided by N, I have to take my continuous correction of 0.5 and divide that by N. So what really that means is that 0.5 could get quite a bit smaller, especially if N is quite a bit bigger. Okay, so here we go. I've got it here for you if you really want to see it. But if R divided by N is to the right, to the endpoint to P hat, okay, you can add. If it's to the left, you're going to subtract. I like to actually draw out the rectangle and put that spot in the number line, and then you can decide one way or the other. But here it is. You can kind of pause that and read through it if you'd like. So here we go. Proportional sampling for distribution. So it's kind of strange. It's basically finding the probability of a probability occurring. So suppose that the annual crime rate for Denver is P equals 0.111. So there's the population crime rate for Denver. But we're trying to figure out that if I had 50 people, what is the probability that between 10% and 20% of the residents will fall victim to a crime? So check to see if it works out. So N, which is 50, P, which is 0.11 repeating, that works out to be 5.55. That's bigger than 5, we're good to go. Do the same thing, find Q, which would be the complement of that P, and get 44.45. That's also good to go. So what that's telling us is that we can go through the whole process of finding a z-score, area underneath the curve, and blah, blah, blah. Okay. So the mean I'll use is the 0.111 from above. The standard deviation is the square root of 0.111 times 0.889 divided by 50. Take the square root of them, and we'll use 0.044. Now here's your continuous correction. I just take the 0.5 divided by N of 50 to get 0.01. So I'm going to draw little rectangles here. So I want between 10%, and be careful, make sure you put the 10 and 20% as decimals. And I'll put rectangles above them, and I want to include those rectangles, and it's the area in between. So I need to get that number by taking 0.10 minus that continuous correction, and that's how that becomes 0.09. Right here I'm going to take the 0.2 and I'm going to add that continuous correction, and that's how that becomes 0.21. I'll go through and I'm going to find z-scores. So there's my P hat that now became an X. There's my other P hat, which became an X as well. Subtract the mean, take the standard deviation. Here's a z-score, here's another z-score. Find the areas. You're going to take and subtract those, and there is your area in between those 2%. So what it means is that there is a 67% chance that between 10% and 20% of those 50 people will fall victim to a crime this year. Okay, quality control charts a lot like what we did in the past. I'll run through one that I got out of the back of the book, or actually in the book. So if I'm going pretty quick, it's don't remember the page number, but it's within 7.3. It's kind of the idea of figuring out whether or not a certain probability is within the acceptable parameters. So maybe crime is out of control either by it being like 2 standard deviations away, 3 standard deviations, and whatnot. I took a quick little snapshot of the process. Something a little bit different and I want to run through is this P bar. It's not the same thing as P hat. So again, P bar is not the same thing as P hat. P bar is the total number of observations in all the samples divided by all the number of trials. And then you can use that to figure out your standard deviation, kind of a lot like what you did, but now it's instead of P and Q, it's P bar and Q bar. And Q bar is just your 1 minus your P bar divided by N. Be careful, N is how big the samples are. Out of control, 3 standard deviations away, 2 of the 3 being 3 standard deviations away, 9 standard deviations away, 2 of the 3 being out of the way. So it's all the same out of control symbols. Where your lines go are, again, 2 and 3 standard deviations away, above and beyond, or above and below, so there's the plus minus. So here's the actual problem I came from. It's an anatomy and physiology that's taught each year. The course is required for several popular health science majors, so it always fills up with a maximum of 60 students. So each of these groups is 60 students. To get that number, it would be the number of successes, 9 out of 60. Okay, so the total number of R's is going to be 9 plus 12 plus 8 plus 15 plus 6 plus 7 plus 13. You get the idea. You're going to add up all those. And like I said, I got this guy from the book. I get the page number for you. There we go. So it's page 384. The total number of R's is 147. Now, don't get tricked because in each of these is 60 people, 60 people, 60 people. So I'll take 14 times 60. 14 coming from the 14 groups. So 147 divided by 840, there's my P bar of 0.175. Okay, to find my standard deviation, I'll take the square root of the 0.175 times the complement of that 0.825, but don't divide by 840. Make sure you put in the 60 because each sample is an n equal to 60. So there's my standard deviation of 0.049. Here's what the final thing looks like. So there's my mean. There's 2 standard deviations above. There's 3 above. I'll do the same thing, go 2 below, go 3 below. There's my boundaries. And each of these points is the probability that went with each one. So this would be in the first group, the probability of getting an A was 0.15. So you put the point roughly at 0.15. Now this particular chart is out of control because right there is a number that is at least 3 standard deviations away. So it's out of control. All right, so that's the idea. Again, there's some homework problems for you. They're all odds, so you should be able to check your answers in the back of the book.